Hi and welcome back. In this video we're going to talk about or begin talking about delegation. Delegation again is a design pattern. We usually use it between the model of an application and a view controller or a controller of some kind. And it's a way to get the controller to do things on the behalf of the model. So we're going to explore this a little bit in this discussion, and then we have a demo or two to familiarize you with the concepts involved. So delegation, as we already said, is a design pattern in which one object, that we call the delegate, performs methods in response to events that occur in another object. We call that the delegating object or the delegator. So how does this work? Well, the delegator either declares or imports a protocol. And we're going to look at the definition of a protocol here in a moment. And that protocol will contain method declarations. And these are methods that the delegator needs to have performed, but it doesn't really care who performs these methods. And then the delegate class imports and instantiates the delegator. And it also, by the fact of importing it, it gets that protocol. And then it defines the method bodies that are in that protocol. So the delegator is asking the delegate to perform methods in response to some kind of event that happened. And then it doesn't care how the delegate performs those methods. The delegate defines the way that the methods are actually performed. So this works in Objective-C using dynamic binding. And dynamic binding is the state in which an object's identity isn't resolved until runtime. Static binding, on the other hand, occurs in Java, for instance. Everything has to be known. The identity of all objects has to be known at compile time. But with dynamic binding, we don't know the identity of objects. The compiler doesn't know the identity of objects at all. Only the runtime system finds out and binds those objects. This means that at compile time, when we write the code, the delegator class doesn't need to instantiate the delegate, and it never really knows, it never needs to know, and it really never knows what object actually is the delegate, what object performs the methods that are declared in its protocol. So the delegator declares a property. And this property is of type ID. Why? Because it doesn't know what class the delegate is going to be. So the delegate declares an ID property, and this represents the delegate class. And this points to the protocol using angle bracket syntax. So here's the property declaration for a delegate. It's not atomic, and we're using unsafe unretained, and we'll talk about this in the next slide. This is kind of like, this is another storage qualifier or setter semantic. We have strong, we have weak, we have assign for C primitives. Now we have unsafe unretained, and we'll talk about this in the next slide. And then ID, and then in angle brackets, the name of the protocol. Here we call it my delegate. And then by convention, we named this property delegate. We could name it anything, but just to keep things straight, we conventionally name this property delegate. So what about this unsafe unretained thing? Well, unsafe unretained is like weak, except that it doesn't nil the pointer when the object is deallocated. So actually it's a little bit more unsafe. But for delegates, it turns out this is actually what we want. Prior to iOS 4, we used assign with delegate properties. And assign, we remember, works for C primitives. All assign means is when I set the value, just change the value. Don't worry about the old value. Don't cache it. Don't release it. We don't need to. So unsafe unretained does the same thing as assign. Just reassign the value. Don't worry about the old one. We can also use weak. But if you use weak, be aware that weak was defined in iOS 5. It's only supported in iOS 5 and 6 at this point. It will be supported in 7 and so forth. And weak will also nil the pointer when the object is deallocated. So if you use weak, make sure that you understand that that pointer will be nilled. If you used unsafe unretained, the pointer will not be nilled when the object is deallocated. So, we've talked about the delegator. We've talked a little bit about this protocol thing. What about the delegate class? Well, we already said the delegate class imports the delegator, and by extension, it imports the protocol, because the delegator is either importing the protocol or declaring it right in line. It must declare itself, the delegate class must declare itself to be the delegator's delegate. So we already have a property called delegate. The delegate class needs to declare itself to be the delegator's delegate property. So we do this. We already have a property for the delegate class. It's been instantiated. So we do this by using the self.delegator.delegate property and setting that equal to self. This makes the delegate class the delegator's delegate. Follow that through. I'll say it again. It makes the delegate class the delegator's delegate. Now notice that this happens in the delegate class. The delegator doesn't know, nor does it care, nor does it even want to know what the identity of the delegate class is. But the delegate class knows who its delegator is. We can also use self.delegator and then send the setDelegate message with self as the parameter to that. These are functionally identical. The delegate class also has to adopt the protocol, and it does this again by using the angle bracket notation. So here we have a delegate class called myDelegateClass that is a UI view controller subclass, and then in angle brackets we have adopted myDelegate. After it's got that, it must also implement all the required methods of the protocol. We'll talk about required in the next slide, I believe. So once all this hookup is done, we can think of the delegator object as a student raising her hand in a classroom. The student is the delegate object. I'm sorry, scratch that. The student is the delegator object. The teacher is the delegate. Everything the student can come up with to say in the classroom, good and bad, is the protocol. And it's up to the teacher to make a suitable response or not to the student. Some of these things that the student can say are more critical than others. So the more critical ones would probably be required methods of the protocol, and the less critical ones that the teacher would not need to respond to, let's say, would be the optional methods of the protocol. So what does a protocol look like? We define a protocol between a pair of @protocol and @end directives. Protocol will only contain method declarations. It won't contain definitions. In iOS 5, a protocol can also contain properties, but we're not going to talk about that right now. We'll get to that later if and when we need to. The methods of a protocol are required by default. So if we just list a bunch of methods inside a protocol and don't use the keywords required or optional, they're going to all be required. They may be marked as @required or @optional by preceding method prototypes with either @required or @optional. So let's look at the definition of a simple protocol. Here I have a protocol called partDelegate. And we declare count did reach reorder level for a particular part with an integer value of count as a parameter that returns nothing. And we also declare count did reach 0. Now these two methods are required. In other words, the delegate is going to have to respond to these two methods if it adopts the partDelegate protocol. Then we have an optional method. Count has not changed in some days or fraction of days. So we may or may not need to respond to this. The delegate class can adopt this protocol, and it doesn't have to respond to this count has not changed in a certain number of days. And then again, we have another method. If we had a bunch of optional methods, we could just list them under the keyword optional. And then again, the last method, part number changed, we do want the delegate to respond to that. Let's say we want the delegate to respond to that by returning a Boolean value, and we want to pass the new part number to the part number changed as a parameter, as a string. So this is a protocol declaration. Now, as I say, this protocol declaration can be in a separate file, defined as a protocol, or it can be made inline within the delegator class, or the class that actually needs these methods responded to, or wants to have the methods responded to by the delegate. So now that's a lot of words that I just said. The hard thing about talking about delegation and teaching delegation is that verbally it doesn't make a whole lot of sense. The light bulb only goes on when you first look at some code that contains delegation, which we're going to do in the demos, and then do delegation yourself. I will say that delegation occurs very frequently in the Foundation framework. In fact, delegation occurs right there where you can see it, in the app delegate. And there are methods in the app delegate, like application did finish launching with options. Application will become active. Those are delegate methods. And the entire app delegate class adopts the UI application delegate protocol, where those methods are declared, and it implements all the required methods that are contained in that protocol. So when one of those events happens at the application level, the app delegate responds to it. And then if there are return values, it returns those values to whatever class called them. Okay, so take a look at the demos and have fun understanding delegation. Thank you very much.